Hi guys, so at this point you should have already looked at your do now, otherwise we're going to take a look at it together right now. Number 1, state the solution to the system of equations graphed below. Now remember that a solution to a system of equations is a point of intersection. So in the graph below I have two linear functions graphed and their point of intersection is right here. I want to write it as an x comma y because it's a coordinate point. So if I go down to my x, it's going to be the point 1 comma, and if I go across to my y's, 5. So 1 comma 5 is the solution to that system of equations. Number 2, state the number of solutions to each system. So once again, I'm looking for how many points of intersection we have here. So in the first one, I have a circle and a line. So it's going to touch right here. And then once again, it touches over here. Maybe a little confusing, but remember that this line has an arrow, so it's going to keep going. So the first picture has two solutions because it has 2 points of intersection. And then the next one, I have a parabola, and then I have another picture, which is known as an ellipse. We haven't talked about that, but it doesn't matter because we just want to find the number of solutions or the number of intersections. So 1, 2, 3, 4 solutions or 4 points of intersection. So today our goal is going to be to find points of intersection. So after 42 minutes, I can find the points of intersection for two functions graphically. And we're going to use our calculator to do this. So number 1, state the solutions to the equation h of x equals k of x, rounded to the nearest hundredth. So a couple of important things. H of x equals k of x tells me I want x values only. And remember, rounding to the nearest hundredth, you want to round at the end. Nearest hundredth is 2 places. So h of x is given to us, it's this long polynomial function, and k of x is given as an absolute value function. They want to know the solution when they equal each other. So 2/9 x cubed plus 8/9 x squared minus 16 over 13 x plus 2 equals negative the absolute value of 0.7 x plus 5. Now this is something that we don't know how to solve algebraically. So we're going to use our calculators, and the steps are listed for you over here on the right hand side. They're on your paper as well, and I'm going to go step by step with you in the calculator. So the first thing we want to do is we want to plug our first equation into y1. So I'm going to type in h of x into y1, and I'm going to type k of x into y2. So follow along with me on your calculators. We're going to go to y equals. Remember, in order to get the fraction, you're going to hit alpha y equals, enter. And I'm going to type it in, and you should be doing the same thing on your own. Don't forget to hit the right arrow to get out of the exponent before you hit that plus for the next piece. Okay, so I have y1 typed in, or h of x. For y2, I need an absolute value. So first I need to put in that negative. There are a couple of different ways to get the absolute value. You can hit you can hit, let's go back. You can hit alpha window and it's choice 1, or you can hit math and go to the right and it's choice 1. Either way. And there are those absolute value bars that I'm going to put in 0.7x, hit the right arrow to get outside the absolute value bars, and then a plus 5. So at this point, you should have h of x typed into y1 and k of x typed into y2. So I want to take a look at the graph. So I'm going to hit graph. When you hit graph, you want to make sure that you can see a good picture. In this case, I can see a good picture. If your calculator has a different view, you can hit zoom 6. Zoom 6 is standard. That will always bring you back to this window. So if you have a weird picture going on, hit zoom 6, that brings you back to here. The other thing is we were doing stat plots. So some of you may have your stat plots turned on. Remember, if you need to turn them off, second y equals, enter. Make sure that the off is highlighted. If not, scroll over to it and hit enter. So after you have your graph, once again, you want to make sure it's a good picture. If it's not, we're going to adjust the window and we'll take a look at one of those as we get to it. So you want to sketch a picture. It doesn't have to be perfect, but you want to just get an idea of what this looks like on your paper. So everybody right now, take a minute to sketch your picture onto your worksheet. I'm going to click and drag because I have that option, but you guys don't. And then after you have it sketched, you want to label it. This was our k of x, and this was h of x. So now I want to find the points of intersection. The first thing is, how many points am I looking for? If I look at this graph, they touch once, twice, and then 3 times. So when I go through the steps on the calculator to find it, I'm going to have to hit the intersection 3 different times because I'm looking for 3 different points of intersection. So hopefully by now you have your picture sketched. Let's go back to our calculators. So in my calculator, I am going to hit second trace. And I am looking for an intersection. So I'm going to hit choice 5 or scroll down to 5 and hit enter. You should now see a blinking cursor. What you're going to do is you're going to use the right and left arrows in order to go over to that point of intersection. So I'm going to start all the way over with that first point of intersection on the left. So I'm going to scroll over with my arrow. Yep, and I hit it too many times. It went too far. So give me a minute to get it back. All right, so now I have my blinking cursor as close as possible to that point of intersection. I'm going to hit enter 3 times. And it gives me a long decimal. We're going to round after. So right now I'm looking for x values only, so I'm going to copy down this x value. So x equals negative 5.174853. That was this one over here. So now we're going to do the next one. So I'm going to go back to my calculator. I'm going to hit second trace again, choosing choice 5 for intersection, and I'm going to use my right arrow to scroll over to that next point of intersection. Get as close as possible, hit enter 3 times. 1, 2, 3. Here's my next point of intersection, x equals negative 1, and then there's your decimal. Copy that down. And then we have to do it one more time because we have 3 points of intersection. So second calc or second trace, choice 5, scroll over to that last point, hit enter 3 times. And then I'm going to copy down that x value. Okay, so I am going to round to the nearest hundredth because that's what the question asked for, 2 decimal places. So my answers are going to be negative 5.17, negative 1.13, and 1.75. You can put them in those curly brackets if you want, or you can just put x equals, put a box around them, anything like that. So let's take a look at the second question. When g of x equals 2 over x plus 2 and h of x equals log x plus 1 plus 3 are graphed on the same set of axes, which coordinates best approximate their point of intersection? This was actually a Regents question, and this reviews logs, which we just did. So I'm going to go to my calculator, and I'm going to type g of x into y1, and I'm going to type h of x into y2. So follow along with me on your calculator as well. Go to y equals, clear out whatever we have in there from our last question. I'm going to use alpha y equals and hit enter to set up my fraction. 2 over x plus 2. And then in y2, log, which is next to the 7, x plus 1, close my parentheses, plus 3. There's no base in this log. That's why I'm using the log next to the 7. If it was like log base 2, I would use alpha window. But this one has no base, which remember, your base is 10. And I'm going to use the log button, which is next to the 7. So zoom 6 or graph, whichever one you want. Take a look at the picture that's sketched for you. Take a minute, sketch this picture on your paper. There we go. Let me just make this a little bit smaller while you guys are sketching your picture. And I'm going to label g of x and h of x. Now, if you notice for this system of equations, there is only one point of intersection right there. That's the point that we are going to be calculating. So once you have that sketched, we're going to go back to our calculators. I'm going to hit second trace, choice 5. I'm going to scroll over using my left arrow to that point of intersection, and I'm going to hit enter 3 times. Oh. There we go. So sometimes it's a little finicky and you just need to hit the right arrow before you hit enter that second time because it wasn't picking it up. But here is my point of intersection. So what you're going to do is copy down this entire number. Both x and y this time because we're looking for a point of intersection. So x is equal to negative 0.92691 and y was equal to 1.863795. So they didn't tell us what to round to, but if we take a look at our answer choices, first of all, x has to be a negative 0.9, so I can automatically cross out choices 3 and 4. And then all of these are rounded to 1 decimal place, or the nearest tenth. So my answer is going to be negative 0.9, comma, 1.9. Because remember, if I'm looking for the first decimal, I go to the next one. That 6 tells me to round up. So our answer is choice 2. Let's take a look at one more question together, and then I'll give you guys some time to practice on your own. So flip it over. Let's take a look at question 3. Which value to the nearest tenth is not, that's important, not a solution of p of x equals q of x if p of x is equal to x cubed plus 3x squared minus 3x minus 1, and q of x is equal to 3x plus 8. So once again, p of x I'm going to put in y1, q of x I'm going to put in y2. So go back to your calculators, go back to your y equals, clear out what you have in there, and type it in on your own while I type it in up here. So once you have both of your functions typed into y1 and y2, our next step is to graph. So if I hit graph here, there's my first picture, there's my second picture. So we're looking for which value is not the point of intersection. Let me check something. I have it typed in wrong because that is not correct. So I'm going to go back and fix mine. Give me 1 second, everybody. X cubed plus 3x squared minus 3x minus 1. All right, let's take a look at it again. Sorry about that. There we go. Okay, so I'm looking for which is not a point of intersection. So we're going to use process of elimination. But the problem is right now, I don't see a full picture because if you look at the top of your graph, it kind of looks like those two will eventually touch again. So we're going to adjust our window. So you're going to go to Window, and I want to see a bigger picture in terms of the y value. So I'm going to scroll down to my y max, and it's kind of like guessing and checking. I'm going to start with 20. So I'm going to change my y max to 20 and hit graph and see if that fixes the picture and see if I can now see the point of intersection. And there we go. I can now see 3 points of intersection. We're looking, of course, for which is not. So there's going to be one of them in the multiple choice that does not work. So right now, sketch your picture on your paper. I have 3 points of intersection. And we just want to make ourselves a note so this way you remember our window. We changed. We made the y max 20. Now let's say the y max of 20 didn't work. You would just go back, hit window again, change your y max to let's say 50, and you can play around with it. You can change your y max, your x max, your y min, or your x minimum. All right, so here we go. We're going to go back to our calculator. This is the last one I'm going to do with you, so make sure you're paying attention. Second calc. Choice 5 is intersection. I'm using my left arrow to get me to that first point of intersection on the left. I'm going to hit enter 3 times. Negative 3.942 and so on. So I can cross off answer choice 1. Then I'm going to go back to my calculator again. Second trace, choice 5. Scroll with your right arrow to that second point of intersection. Hit enter 3 times. X equals negative 1.1. So my answer is not choice 2. Go back to my calculator. Second trace, 5. Keep scrolling using your right and left arrows so I can get to that point of intersection. I'm going to hit enter 3 times. X equals 2.05. So it's not choice 3 because that rounds to 2.1. Our answer is choice 4. So that's how you find points of intersection using a calculator. The steps are on the front in case you need a refresher. You're going to continue with this packet till the end and do as much as you can.